Let's talk about rationalizing a denominator. So rationalizing means turning something into a rational number, as opposed to an irrational number like a square root. So the idea here is at some point mathematicians decided they don't like expressions to have a square root or other irrational value on the denominator of a fraction. So they want to rearrange that value so that any irrational parts of the expression are only on the top of the fraction and not on the bottom. So how do we do this? To get rid of radicals in the denominator, if the whole denominator is just a radical, square root of something, cube root of something, then you can just multiply that radical. You can multiply by that same radical. If it's a cube root, you would need to multiply twice, so there are a total of 3 of those. But of course, as you do this to not change the value of the expression, anything you multiply on the bottom, you have to also multiply on the top. So then if there is a radical with other numbers added to it, subtracted, multiplied, divided, but especially added, subtracted, or even a radical plus another radical, then what you need to do is multiply by the right thing. It's going to be the same, except you're changing a plus to a minus or a minus to a plus. So if you have a plus b in the denominator with a and b being potentially numbers, radicals, etc., then you'd use those same numbers and radicals, but minus instead of plus, and multiply the top and the bottom by those. And what will happen is you'll get a difference of squares on the bottom. So a plus b times a minus b is a squared minus b squared. The middle terms cancel out, or the outside and inside. So the outside and inside terms would still have a radical in them, potentially, but they cancel out, so it's fine. So you're going to, in effect, square each of those terms on the bottom. So let's look at some examples of this, so it makes a little more sense actually seeing what's happening. So 1 over square root of 3, we could multiply that square root of 3 by another square root of 3, because square root of 3 times itself, that would be the square root of 3 squared, and that's just 3. But if we do it on the bottom, we have to do it on the top as well. So we end up with square root of 3 on the top. We're fine with that. And then on the bottom, just a 3. Those 3's can't cancel each other out because one's inside a square root and one's not. We just have square root of 3 over 3. Next example, 5 over 4 square root of 2. I don't need to do anything with the 4, but I'm going to multiply the top and the bottom by square root of 2. So I end up with 5 square root of 2 on top, and on the bottom, I'm going to have 4 times 2 square root of 2 is just 2. So 4 times 2, so 5 square root of 2 over 8. And then the last example here, we have multiple terms on the bottom with square roots. So I look at that whole denominator and I'm going to have the exact same thing, but with a plus instead of a minus. So square root of 3 plus 3 square root of 2. And then I have to multiply the top by that same thing as well. I'm going to put some parentheses on things here to make sure we're doing this correctly. Have things grouped as they should be. And so we're going to need to distribute on the top. So we have square root of 2 times square root of 3 plus square root of 2 times 3 square root of 2. On the bottom, doing some foiling here, square root of 3 times square root of 3 is just 3. But then you can FOIL it. But really, the whole point that we did this is to know the outside and inside terms are going away. But if you just want to double check, we're going to have a negative 3 square root of 2 times square root of 3 for the inside, and a square root of 3 times 3 square root of 2. And so there's just a negative and positive form of the same thing. They're going to cancel out. So we really just need the square of the first thing. So let's write it that way. The square root of 3 squared minus the square of the second thing. So the square of 3 square root of 2. So on the top, square root of 2 times square root of 3, I can multiply the 2 and the 3. That's square root of 6. then the square root of 2 times 3 square root of 2, the square roots of 2 times each other just turn into a 2. If you need to write that as square root of 2 squared to see that, certainly feel free. But so we end up with square root of 6 and then plus 6 on top. On the bottom, square root of 3 squared is 3. And then we're squaring the 3 and the square root of 2 each. So we have then 9 times 2. And so that's 3 minus 18, which is negative 15. So we can write that as square root of 6 plus 6 over negative 15, or negative out front of the whole fraction of square root of 6 plus 6 over 15, or apply the negative to the top and have negative square root of 6 minus 6 over 15. Any of those would be acceptable. So that's rationalizing the denominator. You won't necessarily do this exactly in the course, but there's other processes you're going to do that are kind of building on and using a similar concept. And there really is a square root involved in it. It's just kind of out of sight. So that's in section 1.3.